Hi guys, this video is the continuation of my previous two videos on section 7.4 where I taught you guys the cross product, the determinant, and how to solve such problems. So if you guys want to watch that, I'm going to post the link in the description below. So now let's do this problem. Find the indicated vector or scalar without using formula. So here we have to find I hat times j hat dot product with 3j hat times I hat. So how do we do this problem? I told you guys in the previous video, but let's just do a review. So you need to draw a circle and make sure to place these I hat, j hat, and k hat in order. And if you guys go in the clockwise direction, so like I hat times k hat. So okay, so you're going I hat times k hat. So this gives you j hat. So you guys gonna go right. I hat times j hat gives you I hat times k hat gives you j hat. Now, if you guys go, it is positive because you're going in the clockwise direction. So every time you go in the clockwise direction, you need to put a negative. So like, again, if you go like k hat times j hat, so what does it give you? K hat times j hat, so it's negative I hat. So I'm gonna write k hat times j hat equals to negative I hat. Okay, so now if you guys go in the anti-clockwise direction, now what does it give you? So now let's do that. So if you guys go in the anti-clockwise direction, so I hat times j hat, I hat times j hat gives k hat. I hat times j hat gives k hat. So here there's no negative. So every time you go in the positive direction, there is a negative, but if you go in the counterclockwise direction, it's positive. So like similarly, if we do j hat times k hat, so j hat times k hat is I hat, positive, right? Because we're going in the counterclockwise direction. So now let's do the problem. So for the problem, first we need to find what is this, like I hat and j hat. I hat times j hat, what is it? So I hat times j hat. So we're going in which direction? We're going in the counterclockwise direction. So I hat times j hat. So remember I just told you guys counterclockwise direction means positive. So it leads to positive k hat. So the answer to this gives us k hat. Now we need to find the answer to this one. So we need to find first what is j hat times I hat. So let's do this. J hat times I hat. So now we're going in the clockwise direction. You see j hat times I hat. So j hat times I hat leads to k hat. But since we're going in the clockwise direction, it needs to be a negative. So we have j hat times I hat gives negative k hat. So there we have 3 times negative k hat. So now let's write this in here. So we have k hat dot product with 3 times negative k hat. So here, since these two guys are multiplying, so here this gives k hat dot product with k hat, and we can factor out the negative 3. So negative 3 factors out, and k hat times k hat. And in the video that I made on dot product, I told you guys that if you dot product one with the other one, like one with the same one, so like I hat times I hat, j hat times dot product with j hat, so these gives, it is same as doing magnitude of k hat to the square. So just remember this property. This is very important. So here we have -3 times magnitude of k hat to the square. Now, do you guys remember that I hat, j hat, and k hat are unit vectors? And what is the magnitude of unit vectors? Yes, you're right. So it's 1. So here we have 3 times 1 squared, which simply gives -3. So -3 is the answer to this question. And also, here it says find the indicated vector or scalar. So how do you guys know that the answer is a vector or a scalar? So remember in the video that I made on dot product, I told you guys that if you commute the dot product of two vectors, it gives a scalar. So um, here when we were doing the cross product, we found the vector, and here again we found a vector, but then we were doing vector dot product with a vector, and dot product gives a scalar. So my final answer is a scalar. Now moving on to another example. Here we have to determine if these 4 points are coplanar or not. Coplanar means they lie on the same plane. So like here, x, y, z. So x, y is one plane here. Y, z is one plane. And x, z is the other plane. So they lie on the same plane. Like one is in here. So like all these points lie on like on this plane or on this plane or on this plane. So like they all lie on the same plane, but they should not lie on different plane, you know. Like wait, I'm gonna show you. So they should not lie on different planes. Like x, y, z. So here point 1 lie here, point 2 lie here. These are different planes. So that means these points are not coplanar. So how do we calculate that numerically? So there is a formula to do that. So the formula is we need to find A dot product with B times C. This is the formula. If this leads to 0, which indicates that the points are coplanar. So you just need to find that, and geometrically this formula is same as finding the determinant of 3 by 3 matrix. So now let's try to solve this problem. So first, in order to write these points in form of determinant, what are we gonna do? In form of a matrix, I mean. So first, we have to find the distance from P1 to P2, P1 to P3, P1 to P4. So this will give us 3 points and will form, 3 vectors, and will form the matrix of 3 by 3. So now let's do this on the next page. First calculating P1, P3, P2, so P1, P2. So this is like we do P2, the point P2 minus P1. So this you have to remember. So when we're finding the distance between P1, P2, it is the same as subtracting P2 minus P1. So it's the inverse, like P1 minus P1, P2, so P2 minus P1. So now what's my P2? So point 2 is 4, 0, -3, minus 1, 1, -2. So we do 4 minus 1, 0 minus 1, -3, -2. So here we have 3, -1, and negative is a positive. and -3, +2, so we have -1. So this is P1, P2. Now let's find P1, P3. Calculating P1, P3, P1, P3. Here, first we did P1, P2, distance from P1 to P2. Now we're doing P1 to P3, and at the end we'll do P1, P4. Now P1, P3 is same as point P3 minus P1, so it gives 1, 5, 10, minus 1, 1, -2. So if you commute that, so then 1 minus 1, -5 minus 1, 10 minus 2, 0, -6, 10 plus 2, 12. So this is my point P1, P3. Now P1, P4. So if you follow these steps, you should get -8, 1, 6. So here I just wrote these steps for you guys if you want to calculate P1, P4. So this is my point P1, P4. Putting our points all together, we have now write it in terms of a matrix. So we have first one. Yeah, make sure to write these in order, otherwise you'll get a wrong answer. So first matrix P1, P2 goes here, and the second one goes below it. Third one here. Now this is to find the determinant. I explained how to find the determinant in my previous videos. The first video on section 7.4 cross products. So you guys can watch that. I'm gonna post the link in the description below. So if you find the determinant, this gives 0. And since the determinant gives 0, so these points are indeed coplanar. Thanks for watching. Bye.